We're going to start recording. So if you got in a little bit early today, you probably heard Miss Blasioli going over the lesson 4 video with some students. That's something everyone should have watched and followed along with before coming to class today. Tyler, are you going to be coming to class? If so, your camera needs to be on and stay on. Those of you who watched today's video, we're moving into a different area of fractions. What skill are we practicing? Actually, not just practicing, what skill are we learning, introducing today? Colin?
Dividing fractions into smaller fractions.
Okay, so we're not actually going to use a division symbol, but we're going to take a fraction and then we're going to split it up into more pieces, but then show how that fraction is equal to our original fraction. Can I have the document, Cam? Does anyone know what that's called? When we have two fractions with different names, different numbers, but mean the same thing. Finn?
They're equivalent.
Very good. They're equivalent, which means they are equal. Very good. So you guys are pretty lucky because you get me second round, which means I teach, and you guys see when we're in school, but today we went through some problems and we did a lot of practice problems on page 14. And then we moved on and did some more practice. And then a lot of the kids said, I was so confused. But then once we did the problems on page 15, it made so much more sense to them. So I'm going to switch up the order that we do it in because I think it's just going to make more sense to you, okay? So I want you to turn to page 15 in your student workbook, please. 15. We're going to kind of skip around today. Everyone should have a pencil, your workbook, nice solid area, somewhere to write. Bella, can you see my workbook? Okay. Izzy, go ahead and read the directions for number 2, please.
Total length of each tape diagram represents 1. Decompose the shaded fractions as a sum of smaller unit fractions in at least 2 different ways.
Okay, so the first thing that we're going to do is we're going to look at this fraction. Soren, this whole thing is my whole. It's split up into 3 pieces. So what should I label each piece?
1/3.
So this is a third, this is a third, and this is a third.
Mm-hmm.
So can you tell me what fraction these 2 shaded pieces represent?
2/3.
So I'm going to write 2/3 on top here.
It's not 2/3. It's halves because the bracket ends when there's only 2.
The total length of
2 halves.
No, hold on, Soren, you're correct. The total length, Colin, of each tape diagram represents 1. So this is the whole tape diagram. This is showing the fraction that the directions are different today. This whole thing is 1 whole. Do you understand?
Yes, but what page is it?
15 for the second or third time, Tyler. Colin, do you understand why this is not 1 1/3?
Yeah, I understand.
Okay.
I just saw the bracket and immediately thought back to what we did
before. The difference today is that each of these is going to represent 1. So now what we're going to do is we're focusing on this shaded area. Now we're going to decompose and we're going to change this fraction to mean something else. So now what I want you to do is I want you to go ahead and split each of these in half, each of those pieces. Olivia, now what does each piece represent? Count all of these up. How many do we have total? You're muted.
6/6.
Okay, so the total there's 6/6. What would 1 be worth?
1/6.
So Olivia, count for me the shaded area.
1/6. 2/6. 3/6. 4/6.
Now below here, I'm going to label this 4/6. So when it's broken up into different size pieces, you label it as different fractions. So my purple pen, which I don't know how well you can see, I'll get some other colors to use, but my purple represents 2/3 because my gray shaded, this was 1/3 and this was 2/3. And then when I switched to my black pen and I did 1/6, 2/6, 3/6, 4/6, what do you notice, Olivia, about the shading of 2/3 and 4/6?
That they both add up.
Are they the same or different shading? Amount of
It's
shading.
the same amount.
It is because it's exactly one on top of the other. So now I'm going to show you how you can use multiplication to prove that these are equal. So I want you to write right beside here 2/3 and 4/6. Numerators and denominators are just like brothers and sisters. They get very jealous of one another. So whatever you do to one, you have to do to the other. So this is how you can prove that they're equal. You want to start, and luckily we have both numerators and denominators filled in, but I like to start with the denominator. It's usually easier for me. So now I'm going to think, does 3 times anything give me 6? Briley with a B. Does 3 times anything give me 6, Briley?
3 times 2.
So 3 times 2 equals 6. I have to do the same thing to the top number to prove this. So Briley, what did I do to my denominator?
3.
What did I do to my denominator?
You timed it by 2.
I multiply by 2. So what am I going to do to my numerator?
Multiply
By what?
2.
What is 2 times 2?
4.
Okay, so 3 times 2 does equal 6. 2 times 2 does equal 4. So I can put an equal sign here. And I just made 2 equivalent fractions. Briley, read this for me. How do I read this now? You can ignore the multiplication. Read this fraction.
2/3
Is equal to,
is equal to 4/6.
and we showed that with proof using multiplication, but also right here with your picture. So these are equivalent fractions. They're equal to one another. Okay, let's try another one. Carson, what fraction does this represent?
Two-thirds.
So right here I have 1/3, 2/3. So again, I have the fraction 2/3. So I'm going to label that as 2/3. This time, I'm going to break my fraction up each piece into 2 pieces. So now I'm going to take this black marker and I'm going to break this third into 3 pieces, this third into 3 pieces, and that third into 3 pieces. I want you to do the same thing. You're splitting each third into thirds now. Now, Sophia, each of these squares represents what fraction?
They represent 1/9.
Now I want you to count by ninths for me till I go through the shaded area. Go.
1/9, 2/9, 3/9. 1 second, my grandma's calling me.
She's working, Grandma.
Sorry, my
That's okay. So we were at 1/9, 2/9, 3/9.
3/9, 4/9, 5/9, 6/9,
So
7/9.
now,
Oh yeah, 6/9.
only the
Yeah, sorry.
shaded part.
6/9.
So now we're going to label the shaded part
6/9.
6/9. All right, so Julian Pletcher, this picture right now is showing what 2 fractions?
2/3 and 6/9.
So do you think 2/3 and 6/9 might be equal to one another?
Yes.
All right, so you're going to help me. We're going to write 2/3 and 6/9 down. Now, Julian, you can start in the numerators or denominators, but do you remember where I suggest starting in? I just think it might be a little easier.
Maybe top.
You can do the top. For some reason, I think the bottom's easier, but we can do the top. So now we just have to prove that this is correct. So 2 times what equals 6?
3.
So Julian, what do I have to do to the bottom?
The same thing.
Which is what?
Multiply by 3.
What is 3 times 3?
9.
So Julian, were both of these true?
Yes.
So what can we say about 2/3 and 6/9?
They're equal.
Very good. We can put an equal sign right here. 2/3 is equal to 6/9. They're the same thing, just broken up into different pieces. It's kind of like this. Let's say, I'll leave that up there in case some of you need a copy. Let's say I'm inviting you over for some pizza, some Hotel Loyal pizza, my favorite. Okay. And so I always make things into a game. So you're going to get to pick if you want pizza A or pizza B. Hotel Loyal, they make their pizzas in rectangles, kind of like a strip diagram. That's probably why I like them. Hotel Loyal is rectangular pizza. Here's pizza A, and it's going to be the same size pizza. Of course, I always get a large, so they're both larges. Okay, now here's the game. I'm inviting one of you over, and I'm going to say to you, you get to pick which pizza you want. You can either have one piece from pizza A or one piece from pizza B. But I'm not going to show you the pizzas. You just have to pick if you want A or B. Tessa, which pizza would you like to share with me? Pizza A? Hotel Loyal Pizza. Mr. Thomas came in. He knew it. I'm not sharing. We only have 2, so he's not getting any.
After 2, we're gonna go.
2 o'clock. Okay. So Tessa, would you like a slice of pizza A or pizza B?
A.
So Tessa, you get this slice of pizza. That's reserved for Tessa. That means I get a slice of pizza B. That's for me. Tessa, what's the difference between your one slice and my one slice?
Your slice is smaller and it's cut into more pieces.
Right. So when you're thinking about equivalent fractions, this is one piece and one piece. So they're the same, but why aren't they equal? Tessa, you got what fraction of this pizza?
1/2.
Tessa got a half of a pizza. Tessa, what fraction did I get?
1/9.
So who got more pizza?
Me.
Right, because 1/2 and 1/9 are not equivalent. They're not equal. Even though the numerators are the same, it doesn't matter. That's why we have to look at how many pieces it's broken up into. So if I tried to make an equivalent fraction, if I wanted to see if that was equal, Tessa, does 2 times anything equal 9?
No.
Does 1 times anything equal 1?
1 times 1.
Okay, so 1 times 1 equals 1. I have to do the same to the bottom. Does 2 times 1 equal 9?
No.
So that means these are not equivalent. That's how the multiplication works, okay? All right, I'm going to unshare for a minute. Okay, so far, do you have any questions? Carson, what does it mean if we're making equivalent fractions?
You're dividing, but not really using a division symbol?
No, we're not dividing per se. You're making different pieces, but equivalent fractions doesn't really have anything to do with dividing. What does it mean if we're making equivalent fractions? We're showing two fractions that are what?
The same?
The same fraction, but with different what?
Numbers?
Very good. Okay, let's go ahead and skip down. Let me think. Let's just go ahead. Let's try letter B. Okay, so letter B, let's look at this fraction. Remember, this is our whole. So Maria Dinkle, what fraction does this purple shading represent?
3/5.
So we have 3 purple out of 5. So you're correct, 3/5. Now we're going to take your marker, your pen. We're going to divide all of these in half. Split them in half. So now we no longer have fifths. Peyton, what does each fraction represent now?
One-tenth.
So now, Peyton, I'm going to shade red, and I want you to count them up for me.
1/10. 2/10. 3/10. 4/10. 5/10. 4/10. 6/10.
Okay, so now in red, the same shading is showing us 6/10. So Peyton, we're thinking right now, what are our two equivalent fractions here?
Three-fifths and 6/10.
Can you prove this to me? Does 5 times anything give me 10?
5 times 2 equals 10.
So then what do I need to do with my numerator?
Multiply it by 2.
What is 3 times 2?
6.
So does 3/5 equal 6/10?
It does.
It does. 3/5 equals 6/10. Okay, let's go ahead and move down to number 3. Marie Dinkle, go ahead and read the directions for number 3.
Okay, draw and label tape diagrams to prove the following statements. The first one has been done for you.
Okay, so now this time we have to draw and prove this. So Trace with a T, I want you to go ahead and we're going to look at letter B. You're going to help me draw the fraction 2/6. What would I do to draw 2/6?
A box with 6 of them.
Okay, so I'm going to draw a tape diagram, and as best as I can, I'm going to break it up into 6 equal parts. 1, 2, 3, 4, 5, 6. So Trace, each of these represents what fraction?
2,
One box represents what fraction?
1/6.
So how many will I shade in to show 2/6?
2.
So I'm going to shade in 1, 2, and then I'm going to label this 2/6. Okay, Brian Davis. Now I need to turn this same tape diagram into 4/12. So I now have to take my 6 equal pieces, and now I need to break them up into how many equal pieces?
12.
So do you have any idea how I can turn these 6 pieces into 12?
Split them in half.
Yep. So I'm going to split them into each 6 into half. Now I should have 12 equal pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm good. Now, Brian, I need to shade 4/12. So how many should I shade in red?
Four boxes.
1/12, 2/12, 3/12, 4/12. I'm going to label this bottom 4/12. Brian, what do you notice about the purple shading and the red shading?
They're both the same.
They're the same. So Brooklyn, you're going to help me write an equation to prove this. We have 2/6 and 4/12. Would you like to start in the numerators or the denominators? You're muted, honey.
The Unimator.
Okay, so does 2 times anything give me 4? Does 2 times anything equal 4?
8.
Now 2 times 8 is 16. What can you add to 2 to get 4? How many times can you add 2 together to get 4?
Is waiting for me to dance, and I am not going to show up for 5 days until lunch. Well, too bad. We're not going to lose tomorrow because you want to
Help her out, Nina. Does 2 times anything?
how much better.
Nina, does 2 times anything equal 4?
2 times 2 equals 4.
So Nina, if I'm multiplying by 2 on the top, what do I need to do on the bottom?
You need to multiply 6 times 2.
What is 6 times 2?
12.
So does 2/6 equal 4/12?
Yes.
It does, because you multiply them both by 2. So this is a true number sentence. All right, let's go and flip the page. Okay, Sarah, we have 3/4 is equal to 6/8. Tell me how I would draw 3/4.
So you draw a rectangle with that was divided into 4 equal parts,
Okay.
and then you shade in 3 of those parts.
And what do these 3 pieces represent? What fraction?
1/4.
All together?
No, I meant 3/4 all together.
Good.
Just one of them equals
Finn,
1/4.
now I need to show 6/8. What can I do to this tape diagram to now show 6/8?
You
Cut
Go ahead, Finn.
each rectangle in half.
There's one cut. There's another. 2 more. So now I have 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, 8/8. Finn, how many do I need to shade purple to show 6/8?
6 of them.
1, 2, 3, 4, 5, 6. Finn, what do you notice about the shading of 3/4 and 6/8?
6/8 is as big as 3/4 or
Oh.
equivalent.
All right, let's go ahead and prove this. Izzy, how can I prove that 3/4 is equal to 6/8?
Multiply for the denominator 4 times 2, because that equals 8.
And then what do I need to do to my numerators?
3 times 2
Equals?
6.
And that's what we have here. So what can I put in between these 2 fractions?
An equal sign.
They are equals. Izzy, can you read this equation? You can ignore the multiplication. Just read this number sentence for everyone.
3/4 equals 6/8.
Very good. Okay, we're going to do one more at the bottom. I've got to get to my last screen so I can hear from everyone today. Riley Roach, I want you to pick a number, 5 or 6.
5.
Okay, go ahead and read it.
Show that 2/3 is equivalent to 6/9 using a tape diagram and a number sentence.
Okay, first thing I want you to do is tell me how to represent 2/3.
Draw a rectangle and draw 2 lines.
Anywhere I want?
No.
Well, then where?
Draw 2 lines to make 3 equal spaces.
There you go. Can't just put them anywhere I want. Okay, so now I have a tape diagram with 3 boxes. Now what do I do?
You shade 2 of them.
Okay. What does my purple shading represent, Riley?
2/3.
Okay, Colin. Now I would like you to tell me how I can now represent 6/9 using the same tape diagram.
Break up each third, break up each of the 2/3 into 3 pieces.
Well, would I only break up these 2/3?
No.
No, I need to do all of them. And you are correct. I can't just split these in the middle because, Colin, if I just split them in the middle, how many pieces will I have total?
4/6.
I'll have 6, and I need 9. So that third needs to be broken into 3. Same with that one and this one. Now, if I count these up, 1, 2, 3, 4, 5, 6, 7, 8, 9. I do have 9. Colin, how many should I shade red?
6.
1, 2, 3, 4, 5, 6. And I'm going to label that 6/9. Olivia, what do you notice about my purple and my red shading?
That they're both even.
Maria Dinkle, can you tell me how I use multiplication to prove this?
You see if you can multiply 2 by anything to equal 6.
Can you?
Yeah. 3 times 3.
So what do I have to do to my denominator?
You have to do the same thing.
What's 3 times 3?
9.
So what can I do to finish this up?
You put an equal sign.
There you go. Now go ahead and read this equation for me.
32 is equal to
No,
2/3 is equal to 6/9.
Very good. Now there's one more thing I'm going to show you today, but it's not a problem on your page, but I'm going to use the book. So I'm going to give everyone a minute to get that written down, and then we're going to do something. Everyone okay? Can I move my book up? You don't have to write this down. I just want to show you something. So you might come across a problem sometimes that says, are these fractions equivalent? So I have 2/4 and 3/12. There's a couple different ways you can think about this. But if you want to go with what we've been practicing, I'm going to take out my pen and I'm going to say, okay, I like to start in the bottom. So Colin, does 4 times anything give me 12?
Yes.
Hold on. I got to change this. Okay, now I'm ready. Does 4 times anything give me 12?
Yeah. 4
What?
times 3 equals 12.
Okay. What do I have to do to my numerator?
You have to multiply by the same thing?
Does 2 times 3 equal 8?
No.
No. So these are not equal. But sometimes kids tend to think, well, 2 times 4 equals 8. So I can think of 2 times something to give me 8 and 4 times something to give me 12. But why is this illegal? Who knows why this is illegal? I'll find someone with the hand up. Why is this illegal? Tanya?
Because you have to multiply them by the same number.
Good girl. Give yourself, you get an extra scoop of ice cream for dinner tonight. Good girl. It has to be the same. Even though it's a 4 and a 3 and they're super close, it doesn't matter. Has to be the exact same thing for the fractions to be equal. Take a deep breath and let it out. That was, if I did yoga, I'd teach you how to do some kind of yoga because I feel like that's what you need after today. Some namaste, that's tough. But I'm kind of glad we skipped over the first page because I really think all of those all that adding today confused the kids that were in school. So I hope that was helpful for you. Does anyone have any questions about equivalent fractions today? Tomorrow, we're into the routine now. So day 1, we watch the video, we do some practice problems together. What do you think we're going to have in store for us tomorrow? Where my voice gets a break because what are you guys going to be doing tomorrow, Izzy?
Like telling you the steps.
You're doing the homework. So today is a lot of the learning and the listening. Tomorrow, you guys are going to show what you know. Also, tomorrow is a chance for you to make some mistakes because after you make the mistake, my job is to help you figure out where you went wrong and we'll fix it, okay? Then you'll do your exit ticket and then it'll be the weekend. But don't forget, what else do you have other than math? Tessa?
Science.
Science. So Tessa won't get this big piece of pizza till her science is done. Yes, Izzy?
Extra math. I like finished all the operations. So do I like still have to do it?
Oh yeah, because guess what? Now we crank the time down.
I already did science.
So you start at 3 seconds. So after you complete it, then customize your program and I see if you can get them faster. So now I'm going to mark you down to 2 seconds. Okay?
Warning, it's a lot harder.
Colin, what are you on now? 1.5 seconds?
Yeah, 1.5 for division.
Mm-hmm. Okay, I'm gonna go ahead, Izzy, and